we also want to be able to write equations if we know what the zeros are and we know what the degree of the function is. So let's take a look at this and see if we can't figure out how to write this. So we've got three different zeros. We have a 0 at -3, a 0 at 5, and a 0 at 0. So if we think back to when we were graphing these, we had a term in that polynomial function of f of x equals, and then we had a set of parentheses that gave us that 0. And the way we found that 0 is by setting whatever was inside equal to 0 and then solving. And that would have given us a -3. So the term that we could put in here is x plus 3. Because if x plus 3 equals 0, then x equals -3 is one of the zeros that we could find. If I know that I have a 0 at 5, I could put another term here in 5. But then because of the multiplicity 2, I need to make sure to put an exponent of 2 on that specific term. Looking at this third one, if I have just a 0, I could either go x minus 0 for that term, or I could just say x. And I could either put that at the back end or the front end. The order of these really doesn't matter as long as we have all of those. Now, the other condition that it gave us here was that we wanted this to be a degree 4 polynomial. Well, the way we look at that, we've got a first degree, and a second degree polynomial all multiplied together. So the 1, the 2, and the 1 added up would be a fourth degree polynomial. So this would be the polynomial function. Now, sometimes instead of given information like this, we could potentially be given a graph and asked to find the function that way as well. So if I had a graph, let's say a graph of a polynomial that looks something like this, I know that I've got an x-intercept at -6, an x-intercept at -2. Let's say that intercept is over at 3. And I want to be able to write the polynomial function based off of that graph. Well, I know 3 of the zeros here, and I've got an idea of what this end behavior looks like because both sides are going down. So first thing I would do, I'm going to set up my function, f of x equals, I know I have 3 different terms because I have 3 different zeros. From the -6, I can say I have an x minus, or an x plus 6, because I want to go the opposite of the sign. The -2, I could say I have an x plus 2 for that term. And the +3, I could do an x minus 3 for that term. Now I need to be able to match what's happening at those intercepts. So at the +3, I know it has to be an even power on that term because it's not crossing over. So I'm going to put a 2 there. But at each one of these here, the -2 and the -6, I can leave those as odd exponents because we're crossing through. Now, the last thing I want to look at is how many turning points do I have and what's the end behavior. So right here, I've got 1 turning point, 2 turning points, and 3 turning points. So 3 turning points means I need to be at least a 4th degree polynomial. So no matter how many turning points I have, the degree of the polynomial needs to be at least 1 bigger than that. Or I could think about it the other way. If I knew the function was a 4th degree polynomial, it has at least 3 turning points. Well, let's make sure that this is a 4th degree polynomial or more. I've got a second power, a first power, and a first power, which would add up to a 4th degree polynomial. So this function, x plus 6 times x plus 2 times x minus 3 raised to the second power, is close to being what we want. There's one more thing we need to look at. Since we have a function with and down end behavior, I need to put a negative out front to complete that function. Had this been going both up instead of both down, then I would leave that off and it would satisfy the function. So we took x-intercepts, put them in as the different terms in the polynomial. I looked at the behavior at each one of those intercepts. These first 2 crossed, so I left them as odd exponents. The third one touched or bounced off, so it became an even exponent. And then looking at the number of turning points, we decided it needed to be at least a degree 4, which it already was. And since both of those sides are coming down, it needed to be a negative function.